Hello class, today we're going to be looking at polynomial functions. Today's characteristic, we're looking at end behavior. So let's jump right in. First we're going to define what a polynomial function is. If we let n be a non-negative integer, that means it's positive and there's no decimals and no fractions, then we have several little real numbers that will become our coefficients. They're going to be real numbers, and that first one, a to the n, is not going to be 0. Some of the others could. And then we define our polynomial function as the function f of x is equal to a sub n x raised to the nth term, nth degree, plus a n minus 1 x raised to the n minus 1, plus, and we can have any number of terms in this polynomial, plus a sub 2 x squared plus a sub 1 to the x plus a sub 0. And that would be x to the 0, but x to the 0 would be 1. Let's just give a real quick example of what that might look like in real numbers. So here's an example. F of x is equal to 7x to the 8th minus 16x to the 7th plus 2x to the 6th plus 15x to the 5th plus 3x cubed minus 2x squared plus x minus 82. Notice we didn't have an x to the 4th in there. That's because that's coefficient is 0. And we'll address that in a little bit. So this is a polynomial function with x of x with a degree of n. And in this example, the degree of that polynomial is 8 for this one. So, and what I want to do here is then the coefficient, that a to the nth, right here, and the coefficient of that term is 7. That is called the leading coefficient. It's the leading coefficient because it's the coefficient of the leading term. Now we are going to be getting to graphing these, and when we do graph them, they create a smooth, continuous curve. There's no breaks in them. We don't pick up our pen, so they look, they're fun little things like that. So let's take a look at the leading term test. So when you're using the leading term test to determine that end behavior of a polynomial function, there's a couple things that we are going to be looking at. The first thing we're going to do is look at the degree of that leading term. There are two possibilities in our determinations. That degree, which we also call n, can be even, or it could be odd. Odd being 1, 2, 3, 4. Odd being 1, 3, 5. Evens being 0, 2, 4, 6. Then the other thing that we're going to look at is that leading coefficient, the number before x. Which is the a sub n. And once again, we're going to look at two possibilities. That could be positive, or it could be negative. Now, when we determine the degree and the leading coefficient, that will give us 4 specific options as to what is happening to the end behaviors. So let's take a look though here. We're going to describe on those end behaviors what the movement is of x and y. So we're always going to start out with a statement saying as x moves some way. So x is our horizontal, and it could move to the right, and that would be towards infinity, or it could move to the left, which is towards negative infinity. The y can move up, or it could be rising. We would say y rises, which is approaching infinity, or we could say that it falls, or it approaches negative infinity. So taking a look at just that end behavior, we don't care what's happening in the middle, but the end, if the polynomial has a leading term whose degree is both odd and the leading coefficient is positive, it's going to look like there's one end and you've got some stuff happening in the middle, and that's the other end. Which we're going to say, oops, I'm sorry. Is that, and this is, instead of saying down, up, I think we used to say that in algebra 2. Now we're going to say it as x moves. And in this way, when it's odd and positive, it's going to be moving to the, as it moves left. So as this is moving left, the y is falling. And as x moves to the right, y rises. Can also be written in a little bit of different notation where we don't use quite so many words, where we say as x approaches, and when we go to the negative infinity or left, it's negative infinity, y approaches and falls is negative infinity. Now over here, if the degree of our leading term is even, such as 2, 4, 6, and the leading coefficient is a positive number, then we're going to say as x, or I'm sorry, first we're going to show you what it looks like. They're both sides are going to be going up, kind of like a parabola. So as x moves left, y rises. And as x moves right, y rises. So it rises both directions. Little shorthand notation then, we could say as x approaches negative infinity, y approaches infinity, and as y or x approaches positive infinity, y approaches infinity. Oops, I forgot this one. X approaches positive infinity, y approaches positive infinity. When we get down to here, where the degree is odd and the leading coefficient is negative, it's going to look like this. Some stuff in the middle and the other end. So as x moves to the left, y rises. As x moves right, y falls. Or as x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches negative infinity. And then our last possibility is when the degree is even and the leading coefficient is negative, where both ends are going to be looking down. So we're going to state as x moves left, y falls. As x moves right, y falls. Or as x approaches negative infinity, y approaches negative infinity. And as x approaches infinity, y approaches negative infinity. Put it down so you can see that. So let's take a look at a couple of examples. We're going to use that leading term test that we just went over to determine the end behavior of x to the fourth minus 4x squared. This is my leading term. So the degree of this leading term is 4, which is even. And the leading coefficient of this term is 1, which is positive. So it has end behavior that look like this. So we're going to say that as x moves left, y rises, and as x moves right, y rises. The other way of writing that would be to state x approaches negative infinity, y approaches infinity, and as x approaches infinity, y approaches infinity. That's one other way of stating that. Let's take a look at another one. This one, the leading term is a little bit hard to find. The leading term, when you have multiple factors, is going to be the multiplication of all the leading terms of these factors. So the leading term is going to equal negative 2x cubed times x times x. So we're multiplying this term, and this term. So our leading term is going to be negative 2x, and that's cubed, and 1, so that's x to the fifth. This is the term we're going to use for the leading term test. Now the degree is 5, which is odd. And the leading coefficient is negative 2, which is negative. So when it's odd and negative, it's going to have the end behavior that looks like this. So I will state as x moves left, y rises. As x moves right, y falls. We could also state it as x as x approaches negative infinity, y approaches infinity, and as x approaches positive infinity, y approaches negative infinity. And you're going to try a few of these tomorrow.